Hi, Algebra 2. All right, so today we are going to be working on the blue packet. On the back table, there are 3 packets that you guys should pick up. The blue one, the yellow one, and the pink one. And please be careful because there are some green ones back there as well for one of my other classes. But again, you will need the blue, the pink, and the green. And today blue, pink, and yellow. And today we're going to be working on the green one. So hopefully you watched the intro video before this and are caught up with the other videos that I've posted that are going to lead to this. We are going to go through 2 examples together, and then the 2 on the back side are going to be yours for your practice, and you need to upload those when completed. Okay, so first thing, using figure 1, we are going to state the degree of this polynomial. Okay. Looking that both ends of the graph point the same direction, that means that this is going to be an even degree. Okay, so that's something that I can give myself a hint with here. Okay, and since the right side is pointing up, that means that the A value or the leading coefficient is going to be positive. Okay, so the degree is even, all right, and we know that it's positive. Now I'm going to look for the number of turning points. Okay, remember in the intro video I said the turning points are where the graph changes direction. So the graph started here. Let me pick up a highlighter. So the graph starts here, and it's decreasing, and then right here it has a turning point, changes direction. Okay. Then it increases, and then right here it changes direction again. Okay, it is decreasing and changes direction. So this graph has 3 turning points. Now, to find the degree using those turning points, I can see that I take the degree and add 1, or turn the number of turning points and add 1. So 3 plus 1 gives me a degree of 4. Okay, so this polynomial is going to be positive x to the 4th. Okay. State the domain. Well, since there are arrows at both ends, okay, the domain is going to be x is going to be between negative infinity to positive infinity. Or as a shortcut, we can write all real numbers. Okay. Stating the range. The range is the one where we had a few different options. The range at this point is read from the bottom to the top. So what I'd like to first know is how far down on the y-axis does this graph go? Well, this goes down to, I'm going to call that -7. Okay. So the range for this one is y is greater than or equal to -7. Okay, y can be any value above -7, but it never goes below -7. Identify the zeros. The zeros, okay, we've talked about that before. Zeros are the x-intercepts. So where does this graph cross the x-axis? And there could be more than one. So here it crosses the x-axis, and that point there is at -1, 0. It also crosses the x-axis right here, which is at +1, 0. It crosses the x-axis here, which is at 2, 0. And it also crosses the x-axis here, which is at 3, 0. Okay. Now, to find the y-intercept, where does the graph cross the y-axis? That is at this point right here, where the x is 0 and y is negative 6. So this time it is 0, negative 6. All right. Approximate the area of any relative maximums or relative minimums. Okay. So again, relative maximums and relative minimums, what I'm going to be looking at is the turning points. So this turning point here, since it's the lowest point, that would be a relative minimum. Okay, so it's like where it drops down to the lowest point. So that value there is going to be at negative 0.57. Oops, negative 7. Okay, so that's our first relative minimum. Okay, then I go to the next turning point right here, and that value there is going to be at positive 1.51. Okay. The next turning point is a relative minimum, and that one is going to be at 2.5 and negative 1.5. Okay, so those are my 3 locations where I have a relative maximum or minimum. All right. All right. Now let's go on and describe the end behavior. So this is where we are going to say as x is going to negative infinity. And then again, we're going to look at it as x approaches positive infinity. Excuse me. What is the y value doing, or what is the f of x doing? Okay. Now, even degree, they're going to be the same thing. So whatever the right side is doing is exactly what the left side is doing. So the right side is going to positive infinity. So that means that the left side is also going to positive infinity. Okay. All right, so let's go look at figure number 2. Find the value of the function at each of these values. So at f of 2, so when x is 2, what is the y value at that point? So when x is 2, what is the y value at this point? Well, that is when y is negative 4. Okay. When f of x is 0, so when f of 0, so when x is 0, what is the y value? Well, when x is 0, it's at the origin, so y is also 0. Okay. How about when x is negative 1? What is the y value at that point? That point is also at negative 4. Okay. And when x is 1, what is the y value at that point? In that case, y is negative 2. Right? State the degree. Well, it's going to be an odd degree, okay, because the ends are pointing opposite directions. So it'll be an odd degree. And looking at the number of turning points, we can count the number of turning points and add 1 to that to find the degree. So here's 1 turning point. Here's 2 turning points. So 2 plus 1, the degree is 3. Identify the zeros. I'm going to go ahead and put this as well as x to the 3rd. And it is positive because the right side is pointing up. Okay. Identify the zeros of the function. So how many times does it, or where does it hit the x-axis or cross the x-axis? Right here, where x is 0, 0. And also right here, where that is 3, 0. Find the y-intercept. Well, the y-intercept also happens to be at the origin in this one, so it is 0, 0. Okay? Identify the intervals where the graph is increasing and where the graph is decreasing. Okay, so I'm going to go ahead and just look at this and start from the left to the right, because that's how we read a graph. From this point here, so that actually started somewhere at negative infinity, because it really started way down here. So from negative infinity up until that turning point, which is at 0, 0, the graph was increasing. Then from that turning point down to the, or from that turning point down to the next turning point, okay, that's where the graph was decreasing. That's a horrible color to see, so let me pick up a different color. Okay, that's where the graph was decreasing. Then we go back to where the graph was increasing. And what they'd like to know is, where was the graph increasing and decreasing? Well, it started decreasing at negative infinity. And then right here at this turning point, where x equals 0, okay, that is where the graph was increasing. Then from 0 to where the x value is 2, the graph was decreasing. And then from 2 to positive infinity, the graph is then again increasing. Okay. Approximate the locations of any relative maximum or minimum. Again, we're looking at those turning points. So this first turning point is at 0, 0. That would be a relative maximum. And this point here is at positive 2, 1, 2, 3, 4. That would be a relative minimum. Okay. State the domain and the range. Well, there's arrows at both ends, so the x value will be, x is between negative infinity to positive infinity, or we could write that as all real numbers. The y value, well, how far down did it start? Well, it actually started at negative infinity. So for the y value, we could put from negative infinity, and on the right side of the graph, it goes up to positive infinity. Or we could also say that the range is also all real numbers. Okay? All right. Examples 3 and 4 are yours to practice with. If you get stuck somewhere specifically, write down your question. Try those. There's no harm in trying them. Let's see what you come up with. And then upload this once you have it completed.